Today, everybody, we are starting graphing other trigonometric functions. Everybody say the word trigonometric.
Trigonometric.
Pretty good, pretty good. It's like Nemo saying sea anemone. All right, so right now, what we're going to do is we're going to focus on the very first one called y equals the tangent of x. What I'd like you guys to do is I would like you guys right underneath it, y equals, by the way, tangent is equal to the sine of x over the cosine of x. That's what tangent is actually equal to. It's equal to the relationship of sine to cosine. That's what tangent means. Okay? So go and write that right there on your notes. Now, the next thing that I would like you to do is I'd like you to go to y equals. Okay? Go to y equals. We're going to type in tangent of x. But before you hit graph, before you hit that, I want you guys to go to the window button. I would like you guys to start at -2 pi. Go to +2 pi. Please keep your x scale at pi divided by 2. So every single little tick mark on the x-axis is pi over 2 units. But this time, y minimum, go to -10. And y maximum, go to +2. I want to see a lot of graph on this, okay? And after you do that, keep the y scale 1. After you do that, hit the graph button. Let's take a look at this guy.
I don't like it.
You don't like it?
Mm-hmm.
I like it. Okay, now you'll notice on your paper, you have this graph on your notes. Okay, so right here, could you guys make sure you understand right here, this on your graphing calculator, that's what? Pi over 2. Right here I'm at pi. Here I'm at, no,
pi.
3 pi over 2. And here I'm at 2 pi. So I'm going to label these. I know you guys already have them labeled, okay? But for people watching this video who aren't asleep yet, this is what I want to make sure they're understanding. So this is what your graphing calculator, because each little tick mark was pi over 2. Now look very carefully. All of your zeros, every single time it crosses the x-axis, it's at a negative 2. It's at a negative pi. It's at a 0 pi. It's at 1 pi. It's at 2 pi. So if I said this, where is the tangent of x equal to 0? What would you say? Where is the tangent of x always equal to 0? Wherever there is a pi. So you could say it's at n times pi, where n is an integer. You guys see that's one of the properties that I have listed there in your notes? Okay? The statement number 4. X-intercepts are located at pi n. Right? So your zeros are always located at pi times n, where n is an integer. The next thing I'd like you to do, somewhere on your notes, make a unit circle. I need you guys to make a unit circle somewhere on your notes. Remember, this is when I say notes on notes. Okay? So what I'd like you to do is we are going to break this down into its basics, basic elements. The good news is I'm only going to go 90 degrees at a time. Try to get this straight up, straight down. So I'm making a unit circle. Just follow along. I'm going to put a point right here all the way around. And right now I'm going to label this at 1, 0, 0, 1, -1, 0, and 0, -1. Now remember I said y equals the tangent of x equals the same as saying the, get close to my computer, the sine of x over the cosine of x, right? Now there's some important situations right here. Right now, what can this number never be in a denominator? What would be bad if this was equal to a 0? So let's think about this. When is the cosine of x actually equal to 0? Now, if you can't remember what that means, it means the cosine, by the way, just so you know, the cosine of theta is always the relationship between your x value and your r value. In a unit circle, what's the r value always going to be equal to? It's going to be equal to a 1. So we're looking for where, at what degree is x equal to what? 0. So right now, where am I here? When's x equal to 0? Right here. I'm at pi over 2, or you could call that what? 90 degrees. Over here, where is this? This is at 3 pi over 2, also known as what? 270 degrees. I don't know if you can't see that, that's okay. I'm going to highlight it real quick. The cosine of x is equal to 0 right there and right there. Because what does 0, 1 represent? That represents an ordered pair. This is when x is 0. This is when x is 0. And where is it equal to 0? It's equal to 0 at pi over 2 and where? At 3 pi over 2. Look where pi over 2 is right here. Look where 3 pi over 2 is right here. So what happens? Why does it look like this? Because this right here, everybody, is an asymptote. An asymptote is created. Try to draw a nice little asymptote going straight through there. If you can. Nope. Alright. Do the best. So notice, where are all the asymptotes located in a tangent of x graph? Pi over 2. 3 pi over 2. So basically, what's this? By the way, every single time you make a tangent of x graph, you always get it. Basically, this is called infinite discontinuity. What did I say this little dotted line is called? That's called an asymptote. No, I didn't. It's just called an asymptote. That's what it sounds like. Okay? All right. So we have an asymptote right here. Where is the asymptote located? When x is equal to 3 pi over 2. So if we were to look at your notes right now, look at your notes. This right here. It says, the asymptotes are what? Where x is equal to pi over 2n, where n is keyword odd integer. So what are my odd integers? 1 pi over 2, right? 3 pi over 2. What else? 5 pi over 2. And these could be, I'm going to put plus or minus, plus or minus, plus or minus. Okay? So that's where all the asymptotes are located. The next thing I want you guys to understand, that number 1, it says, what is the period of the graph? Pi. Now what the heck does that mean? So watch. The period, everybody, is the distance between the asymptotes. So on your paper, what you could write, you could do a little double arrow right here, label it period, label it pi, so that you know that the distance between the asymptotes is your period. So for the tangent of x graph, what is our period to start with? Always going to be 1 pi. What's different? Before, what's the sine of x and the cosine of x? What's the period that we typically start with? 2 pi. Now it's down to 1 pi. Okay? So right now, that's something you need to be aware of. That's all the notes we're going to do for today. I'm going to show you how to use this graph to solve the equations. Okay? So right now, let's look at problem number 1. I'm going to go all the way up to problem number 1. And by doing this, you guys should be able to figure out just by the graph. So right now, look at problem number 1. It says, find each value by what? Referring to the graphs. So which graph am I going to look at? I'm going to look at y equals the tangent of x. And what am I going to look for when x is what? Negative 3 pi over 2. So let's look at the graph. What does that mean? We'll find out. You're right. I think you're right. Hold on. Hold on. Let's look at our graph. Scrolling down. Scrolling down. Okie dokie. So here's our graph. All right. So this is at 0. All right. This right here is at negative pi over 2. What's this one right here? This is at negative 3 pi over 2. Hey, look. At negative 3 pi over 2, what is the tangent of x equal to? Undefined. So, all you basically have to do for the first 4 problems is use the notes that I have given you and find the correct answer. So right now, the problem number 1 said what? What is the tangent of negative 3 pi over 2? And what did we say the answer was? Undefined. That's right, because what is drawn there? What's drawn right there at negative 3 pi over 2? Go ahead and say it. No, there's something drawn there. It's a what? It's an